The Dornier Do X emerged from the mind of Claude Dornier, a visionary German aeronautical engineer whose work in all-metal aircraft had already placed him at the forefront of aviation innovation. In the aftermath of World War I, Germany faced severe restrictions on military aviation imposed by the Treaty of Versailles, limiting the country's ability to develop combat aircraft. For designers like Dornier, these constraints were both a challenge and an opportunity. Civil aviation became the new frontier, a realm where technological ambition could flourish under the guise of peaceful enterprise. It was in this environment that the concept of the Do X, a 12-engine flying boat of unprecedented scale, was conceived. Dornier's aim was audacious: to create an aircraft capable of carrying hundreds of passengers across oceans in comfort and safety, a flying ship that would redefine the limits of human mobility. The development of the Do X began in Dornier's facilities in Friedrichshafen, on the northern shore of Lake Constance, where Germany's fledgling aviation industry found both resources and space for experimentation. Engineers faced immense challenges from the outset. The size of the aircraft alone demanded innovations in materials and construction methods. The fuselage, stretching nearly 50 meters, was built using lightweight yet incredibly strong aluminum, reinforced with duralumin spars, a material that had revolutionized aircraft construction in the 1920s. Every rivet, every seam had to be precisely calculated to ensure that the massive hull could withstand the stresses of both water landings and sustained flight. Unlike smaller aircraft, where a single failure could be absorbed by structural flexibility, the Do X's enormous dimensions meant that engineering errors could have catastrophic consequences. From the earliest design stages, aerodynamics presented a formidable obstacle. The Do X needed a hull shape capable of gliding smoothly across the water during takeoff, while minimizing drag once airborne. To solve this, Dornier and his team conducted extensive water tank testing, adjusting the contours of the hull in painstaking increments. Stability on water was another critical concern. 12 engines mounted in 6 push-pull pairs above the wing would deliver immense thrust, but the weight distribution and hydrodynamics of the hull had to be meticulously balanced to prevent dangerous porpoising or uncontrolled tilts. Each design iteration required collaboration between aerodynamicists, structural engineers, and test pilots who had to imagine how such a behemoth would behave in conditions no previous aircraft had faced. By 1928, the aircraft had begun to take recognizable form, its massive wingspan and bulbous fuselage rising from the hangar like a metallic leviathan. The Dornier team faced the dual pressures of innovation and public expectation. News of the project had spread across Europe, and the Do X became a symbol not just of German engineering, but of human ambition itself. Photographers captured images of workers dwarfed by the aircraft's hull, highlighting the almost unbelievable scale of the project. Each component, from the reinforced hull compartments to the massive floats supporting the fuselage on water, was a testament to meticulous planning and the extraordinary technical skill of the German aviation industry in the interwar period. Despite careful planning, early testing revealed the challenges inherent in such an unprecedented design. Engine synchronization proved particularly complex. 12 massive engines required precise coordination, and even small discrepancies could affect lift and handling. Water taxing tests highlighted the sensitivity of the hull to weight distribution, prompting adjustments to the placement of fuel tanks, engines, and cargo areas. The interior design presented another layer of complexity. Dornier envisioned a flying ship that was not merely functional but luxurious. Passenger cabins, lounges, dining areas, and promenades were integrated into the fuselage, requiring additional structural reinforcement to accommodate both the weight and the comfort of hundreds of passengers. Balancing the aircraft's functionality with its ambitious luxury interior was a challenge that demanded both creativity and rigorous engineering judgment. As construction neared completion, the Do X became more than an aircraft. It was a national and international spectacle. Crowds gathered at Friedrichshafen to witness the scale of the flying boat, their amazement reflecting the audacity of its conception. The aircraft embodied the tension between visionary ambition and practical reality, a manifestation of engineering daring on a scale that few could have imagined at the time. It symbolized Germany's attempt to reassert itself as a leader in aviation technology, even under the restrictive conditions imposed by the post-war treaties. In many ways, the Do X foreshadowed the enormous military aircraft that would come to define World War II's. While it was not intended for combat, its sheer size and complexity provided a glimpse of what humanity could achieve when imagination and engineering converged. The Dornier Do X was a marvel of engineering, an aircraft whose sheer scale and technological ambition challenged the conventions of aviation in the late 1920s and early 1930s. Its design reflected a meticulous understanding of aerodynamics, structural engineering, and hydrodynamics, with every element calculated to support a vessel of unprecedented size. The hull alone measured nearly 48 meters in length, and was designed to glide effortlessly across the surface of lakes and oceans, minimizing resistance while providing stability for takeoff and landing. Reinforced with duralumin spars, the structure needed to withstand the immense stresses imposed by its weight and by turbulent water conditions, all while remaining light enough for flight. The designers experimented with hull curvature, step placement, and compartmentalization, ensuring that the aircraft could handle rough water while keeping the enormous fuselage intact. It was a delicate balance between buoyancy, strength, and aerodynamics, a problem that no engineer had fully solved at this scale before. The most striking feature of the Do X was its 12 engines, arranged in 6 push-pull pairs above the wing. Each engine contributed to a combined thrust capable of lifting an aircraft that could exceed 56 metric tons fully loaded. Synchronizing these 12 power plants required extraordinary precision. Even small variations in output could cause yawing, uneven lift, or structural stress. Engineers developed specialized monitoring and control systems, with crew members responsible for adjusting throttle and engine timing in real time, a task demanding skill and intense focus. The engines themselves were mounted in nacelles above the wing to avoid spray during water operations, an innovation that also complicated maintenance and airflow management. These power plants, while impressive, revealed the tension between ambition and practicality. They consumed enormous quantities of fuel, produced relentless vibrations, and required constant attention to prevent overheating or mechanical failure. The wing structure of the Do X was equally remarkable. It spanned 48 meters, almost as long as the fuselage, and incorporated multiple spars, ribs, and struts to distribute weight evenly and maintain rigidity under flight loads. Engineers relied on metal lattice construction, reinforced with lightweight alloys, to withstand bending moments and torsion while keeping weight manageable. Control surfaces were massive and operated with mechanical linkages that demanded precision, ensuring that the aircraft could respond predictably despite its scale. Even minor miscalculations in the wing design could have catastrophic consequences, and each test flight revealed new lessons about load distribution, engine thrust coordination, and aerodynamic stability. Inside, the Dornier Do X was conceived not merely as a vehicle for transport, but as a luxurious flying ship that challenged perceptions of what an aircraft could offer. Passenger cabins featured upholstered seating, promenades, dining salons, and observation decks, creating a level of comfort unparalleled in its era. Engineers had to integrate these amenities without compromising structural integrity, reinforcing the floor and hull compartments to accommodate the weight of hundreds of passengers. Fuel tanks, luggage compartments, and crew spaces were carefully arranged to maintain proper center of gravity, a critical factor for such a massive machine. Every detail, from portholes to stairways, reflected a dual commitment to functionality and elegance, merging the world of engineering with that of human experience. Operational performance demonstrated both the achievements and limitations of this audacious design. Maximum speed was limited to approximately 175 kilometers per hour, a modest pace given the aircraft's size, while climb rates were slow and required careful attention to engine management. Range was sufficient for long, distance demonstration flights, but fuel consumption was prodigious, making extended transoceanic operations a logistical challenge. Takeoff and landing required careful coordination. The Do X needed calm water and precise engine synchronization to rise from the surface, and any misalignment could result in dangerous pitching or loss of control. The handling characteristics of such a leviathan were unlike any other aircraft, demanding highly trained pilots and crew capable of managing engines, controls, and passenger safety simultaneously. The Do X also incorporated advanced safety and hydrodynamic features for its time. Multiple watertight hull compartments reduced the risk of sinking in the event of damage, while reinforced floats provided stability during water taxiing and landing. Water rudders allowed precise steering at low speeds, and the aircraft's high-mounted engines prevented propeller spray from damaging the hull or reducing lift. These innovations reflected a thorough understanding of the challenges posed by flying boats, combining lessons from smaller seaplanes with solutions scaled up to unprecedented dimensions. Yet, the complexity of these systems also meant that operational readiness required intensive maintenance and constant attention to detail, a limitation that would influence its practical use in the years ahead. In combining luxury, engineering innovation, and sheer scale, the Dornier Do X became a symbol of human ambition at the edge of aeronautical possibility. It demonstrated what could be achieved when imagination, engineering skill, and resources converged, creating a machine that was as much a statement of vision as a vehicle for flight. The 12 engines, immense wingspan, and carefully engineered hull embodied a prelude to the era of giant military aircraft that would dominate the skies during World War II. While it was not built for war, the technological lessons learned in its design, engine synchronization, hull aerodynamics, and structural integrity at scale, would resonate through subsequent aircraft, influencing the development of long-range flying boats, heavy bombers, and transport aircraft that became crucial in the coming global conflict. Despite its monumental scale and technological sophistication, the Dornier Do X never found a true combat role during World War II. By the time hostilities engulfed Europe in 1939, the aircraft was already largely obsolete. Military aviation had moved rapidly toward faster, more maneuverable, and heavily armed aircraft capable of strategic bombing, reconnaissance, and transport under combat conditions. The Do X, with its enormous size, 12 engines and slow speed, was ill-suited to these requirements. Nevertheless, the aircraft had achieved a degree of fame and operational experience that reflected the ambition of interwar aviation. Its early flights had captivated international audiences, demonstrating that large flying boats could cross oceans, carry hundreds of passengers, and operate with a level of comfort and luxury unheard of in aviation at the time. These feats, though non-military, provided critical lessons in aerodynamics, engine coordination, structural integrity, and long-range navigation. Lessons that would indirectly inform the design of military flying boats and transport aircraft used in the war. The Do X operational history was a mixture of demonstration flights, promotional tours, and limited civil service. In 1931, one of the aircraft was shipped to the United States, where it undertook a high-profile transatlantic flight from Germany to New York via the Azores, garnering worldwide attention. Crowds gathered at every landing point to witness the enormous aircraft, its 12 engines synchronizing with mechanical precision as it glided over the water. The feat was both a technological and diplomatic success, positioning Germany as a leader in aeronautical engineering. However, the logistical challenges of such missions were immense. Fuel consumption was prodigious, engine maintenance was relentless, and the aircraft required calm water and careful navigation to operate safely. Each journey reinforced the understanding that while scale and ambition could achieve remarkable feats, practical limitations constrained operational viability, an enduring lesson for both civil and military aviation. By the mid-1930s, the Do X fleet faced increasing attrition. Technical failures, structural stresses, and accidents reduced the number of operational aircraft, and the emergence of faster, more capable flying boats and long-range land-based aircraft made the Do X increasingly irrelevant. When World War II erupted, the surviving Do X machines were largely relegated to storage or auxiliary transport roles. Their immense size, maintenance demands, and vulnerability made them unsuitable for military deployment in a theater dominated by agile fighters, bombers, and reconnaissance planes. Any remaining Do X aircraft in Germany or abroad were largely sidelined, their fame remembered more for spectacle than for operational contribution. Nevertheless, the aircraft's design had left an indelible mark. Engineers who had worked on the Do X carried forward knowledge of large-scale aircraft construction, hull aerodynamics, and multi-engine synchronization, skills that would prove essential in the design of wartime heavy bombers, transport aircraft, and other large flying boats used extensively during World War II. The final years of the Do X were marked by decline and dismantling. One aircraft, which had flown successfully across the Atlantic, was ultimately grounded due to maintenance difficulties and structural wear. Others, stored in hangars or at docks, were cannibalized for parts or destroyed during wartime bombing raids. The massive hulls, once symbols of human ingenuity and technological daring, were broken down or left to decay, leaving only photographs, blueprints, and first-hand accounts as testimony to their existence. Yet, despite their disappearance, the Do X legacy persisted. It had demonstrated that aviation was capable of unprecedented scale, carrying hundreds of passengers in relative comfort and navigating oceans with a reliability previously thought impossible. This vision of grand, long-range aircraft would influence both civil and military design in the 1930s and 1940s, foreshadowing the era of heavy bombers, transport planes, and flying boats that played pivotal roles in the global conflict of World War II.